Stanford University.
So thanks for inviting me, and I will start by saying I agree with everything that Edmund just said about the flexibility of the cloud. We also run everything in our environment on the cloud. I guess there's really two things that I think have challenged the world of big data in the last few years. The first is the scale of data, and I think that as the speed of business has increased and as we've had more and more instrumented business processes, the scope and the scale and the velocity and the volume of data has increased dramatically. Title of my talk is 1 billion rows per second, analytics for the digital media markets. This picture here is a picture of 10 years of advertising data for the Financial Times. This was generated by looking at, on the x-axis here we have the temporal axes. On the y we've got price. And the main goal of this picture is to show that there's a lot of data flowing through the online advertising markets. In fact, there are over 100 billion events that occur every day, microtransactions that occur in the online ad markets. That's a large scale of data, and I think that's really that's where this big data meme has really addresses. But I think that the scale issue is one that we're shifting away from. I think scale is an issue that people are now getting comfortable with. I think Hadoop and many of the offerings that people have talked about here at this conference are addressing scale. What I want to tell today is a story about, at Metamarkets, our quest for speed. The challenge of big data isn't just that it's big. It's that if you want to try to get insights out of this large data, it's very slow. And if you talk to many of the startups, data-heavy startups in the Valley, and I'm sure Quora is one of these, when you go to your data and you say, what happened yesterday? What happened in the last hour? Getting an answer to that question isn't something that comes back in human time. It comes back, if you're lucky, it comes back in seconds. But more often, it comes back in minutes or hours. And so the goal that Metamarkets has had over the past 12 months is to build a platform that would allow some of our clients, the world's leading digital publishers, to get insights into their data in human time. And so I'll tell a story about how we built a stack that achieved that. So here's our goal: fast analytics over hundreds of terabytes. Every day we pull in several terabytes of data, add server logs from our various customers. And our goal was to build this dashboard, which I'll actually show you guys a quick demo of that at the very end. So this is our stack. Basically, like most folks, we've got ETL at the bottom. And I guess I'll start by saying that I think ETL has too long been an ignored backwater of organizations. ETL actually is probably among the most important things you can do in your company. And you should not have the engineers that you can't put anywhere else in that team. You should have your best engineers working in ETL. In fact, at Metamarkets, we just brought a former vice president from BlackRock. He was very eager to work in the space of big data, and I said, we need someone in ETL. And he's actually turned out to be a tremendous asset to us. So ETL is at the bottom here. Data is crunched in minutes. And then we're looking to achieve queries in seconds. So our stack is essentially ETL, persistence, and then we've got some analytics, which I'm not showing, but ultimately all of this powers a dashboard. So how do we go from data to a decision-making dashboard? So the first thing we tried many months ago was we used Hadoop to crunch our data, summarize it to a certain extent, and I think that's a common design pattern. If you hear Larry Ellison at Oracle World talking about, Oracle is where your data lives after you've crunched it in Hadoop. Hadoop is a processing layer. It is not a query layer. We stored it in an MPP database. We stored it in Greenplum, and that worked for us for a while. But at a certain scale, it stopped working for us. And we had to find a different solution. The real issue was that we didn't achieve the performance. We had queries that were taking minutes to return when we achieved a certain scale. And that scale was on the order of 10 terabytes. So the next thing we tried was we said, OK, we'll pre-compute the world. We'll anticipate the queries that people might ask on our dashboard. And that actually meant that instead of crunching our data taking minutes for every hour of data that came in, it was taking hours. We were computing all of the possible 2 to the n minus 1 aggregations that we had for customer data, and then storing it in HBase. The problem there is that that did not scale as our customers added more and more dimensions to their data. In fact, you get this exponential complexity. That was a problem. So one of our engineers, figuring that the time was coming, said, I have a better idea. And he came and said, what I think every CTO should be very, very scared of is when one of your engineers says, I want to build my own database. So I said, that sounds crazy, but this engineer is very talented. I said, why don't you try it nights and weekends, and let's see. We'll try it. And sure enough, of course, that probably meant he was spending days and nights and weekends on it. And we developed what we call Druid. And Druid is a cloud-based, distributed in-memory database. And effectively, I'll show the pieces how Druid works. But effectively, we're able to crunch our data in minutes, summarize it, and our queries can happen in seconds. And that speed that I quoted of 1 billion rows per second scanned, ultimately, that's really determined by the size of the cluster. But that's the best benchmark we'd had until recently. So here are the 4 principles of Druid and how we get that performance. And none of these things taken by themselves are unique. But when we put them together, we think we get something that's pretty good. So the first step is we summarize. I think this is what a lot of people fail to do. When they use Hive, they are running queries over unsummarized raw data. That's slow. You rarely care about event-level data when you're asking questions of it. So our first step is we do a first-level aggregation to a certain resolution of time and a certain resolution of the different dimensions of interest. The second thing we do is we distribute the data. So that's very similar to what anyone who's using MySQL and sharding it would do. And that's not that different. The third thing we do is we parallelize all the queries. And here we're borrowing from many of the MPP architectures that have come before. So that gives us a speed up. Unlike in a sharded MySQL instance, when a query effectively is hitting one node, every one of our queries, for instance, we have a cluster now that's got over 1,000 cores. Many of the queries are hitting hundreds of those cores. So we get real massive parallelism for every query. And the truth is we're not CPU bound. Most of the time, it's those CPUs are idle. And then the last thing is we put everything in memory. So we've done a lot of calculations, and we tend to agree with what Kurt Monash has written, is that for certain classes of data, that data will end up entirely in memory. The choice to put something in memory or on disk is ultimately driven by the value of that data. And I think that we know that the cardinality, the cardinality of human events on the planet is not rising as quickly as the costs of memory are falling. So we can expect that we're sort of trying to ride the tide of history here and say that for the types of data that we're looking at, which are essentially human events of impressions or clicks or purchases or actions, that this will make sense to store in memory. And our costs, right now, we're able to cover our costs and pass that on to our customers. We look at everything as the cost of dollars per terabyte per month. And right now, we're able to achieve about $10,000 per terabyte per month of RAM. And we think that number will only fall in the future. So what are some of the consequences of this? First of all, speed. This was our quest. We needed to have everything that when a user sits down at our dashboard, we want them to be able to get an answer back on the order of seconds, usually less than 1 second. And eliminate this sort of chain of data bureaucracy that you often have in organizations where you have a decision maker, they have a question, they hand it to the analyst goes and talks to the DBA pulls the data, gives it to the analyst who makes a pivot table and brings it back to the decision maker. The latency on that is very slow, and that's the second piece. fresher data. When we live in the cloud, we're able to incrementally build our data cube as the data happens. For some of our customers, we can update data as have it available on the dashboard within 15 seconds of it occurring. So just like we know that food tastes better when it's fresh, I think it's fair to say that data has a similar quality. And there's a reason why in Wall Street people are so interested in up-to-the-minute information. Wall Street's a mature data vertical, and many of the trends that we've seen occur there over the last few decades, I think we can expect to see happen in other verticals. So the last piece, and this is, of course, what this panel is all about, is the cloud. We are scalable in the cloud, and that allows us tremendous flexibility for our customers. I think that many startups that we're working with, many publishers that we work with who are our clients, struggle with how they can scale their systems. The nice thing about working with us is you pay as you grow. And we're able to lean on AWS to get, like I said, for instance, we spun up 256 machines yesterday. Took about a couple hours to make sure we had that capacity. That's not something you can do if you're not running in the cloud. So it really affords us tremendous flexibility and really go out and attract big customers and act big if we need to by running in the cloud. So that's all I'll say, and I guess I'll stop with maybe a quick, if I've got time, I'll show a quick demo. Huh? 2 minutes, okay, great. If I could bring this up, let's see here. Okay. So this is an example of our dashboard, and what you're looking at here is one of our customers who's got 12 billion impressions over the last week. And as I click on various pieces of the dashboard, it actually updates in real time. So if I move, let's say, back a week, these queries are all occurring and being fired off to the back end through a RESTful interface in real time. So I can look at a day's worth of data, and that should update here. You should see less money. Or I can click back and look at several weeks of data. So the key here is that we don't pre-compute any of our answers. All of these things are happening on the fly, and as a result, life is a lot better for the decision makers that sit in front of this dashboard and ask questions. So I'll end with that. Thanks very much.
For more, please visit us at stanford.edu.